So basically, let's say you went back in time to assassinate Hitler. Paradox, right? Because then you change, you're not born, blah, blah, blah. Okay, what happens is you succeed in assassinating Hitler, which then locks the universe into a loop. And on every iteration of the loop, you come closer to failing until you fail to assassinate Hitler, and the normal timeline progresses again. And so then, from your perspective as a time traveler, you're like, what the hell? My gun jammed, or I got arrested. From the perspective of the time traveler, then, it looks like the Novikov self-consistency principle, where you cannot change the past, you can only fulfill it. And so that is one potential idea.
Welcome back. I'm here with Dr. Szydagis. Dr. Szydagis, welcome.
Hello.
Okay. So if you could just give the audience a quick rundown on your background, and then we'll get started talking about UAP physics. And, this is a very theoretical discussion, but I think you have a lot of information to share. So with that, go ahead.
Sure. So I'm an associate professor of physics at the university at Albany, SUNY, State University of New York. And I've been here for about 10 years now. And before that, I was at the University of California at Davis. And before that, I got all my degrees, actually, at the University of Chicago. That's my alma mater for everything, Ph.D., a master's and bachelor's as well in physics. And my primary mainstream scientific effort is the direct detection of dark matter. So that's a little bit about me in a nutshell.
Okay. It's fascinating you were talking about dark matter. Okay. There was a prior interview that I was watching, and you were talking a lot about dark matter, and I'm like, this is really fascinating stuff. I had no idea that was really kind of like your focus. So we're definitely going to talk a little bit about that and what that could imply. So UAP physics there have been objects in the sky that the military has not positively identified, right? But has certain characteristics. They call it the 5 observables. Now the 6 observables, if you include biological effects. What is allowing them to travel at these seemingly impossible speeds and accelerations and things like that?
Well, we have to first presuppose that we're talking about a technology. So we have to address that elephant in the room right away, because when we're talking about UAP, we're just talking about something that's not identified, that's unidentified. And so that doesn't automatically mean it's alien spacecraft or craft of some sort of non-human intelligence. So I'm okay with going there, but we just want to establish that that's what we're talking about. We're not talking about UAP, we're not talking about the denotation of UAP anymore. We're talking about the traditional connotation of UAP in popular language of UFO. We're talking about spacecraft operated by non-human intelligence, which we haven't proven, but we have the tantalizing hint, as you said, that suggests that that's a reasonable hypothesis and we shouldn't discard it. So starting from that point.
And just to add to that point, I don't think it's any coincidence that they started adding Chinese spy balloons to the UAP classification. It's almost as if somebody wants to muddy the distinction. Anyway, I just wanted to highlight that, and I think it complements what you just said, but continue. I'm sorry to interrupt. So,
but to go back to your original question, so if I was an advanced civilization, and I'm not taking any side there of, crypto, terrestrial, whatever, extraterrestrial, let's just talk about an advanced technology. Mm-hmm. How could we, hypothetically, explain the different maneuvers that have been not just seen, but also recorded? There's hard data, there's radar data for more than one incident that really corroborate what people have said verbally. So from that starting point, there are several possibilities, speculating from my knowledge of physics of what advanced propulsion would look like, especially propulsion that is required for interstellar travel. Now, one thing we have to keep in mind is that relativistic propulsion actually helps interstellar travelers. So what that means is that the time dilation effect, it works in your favor. So it is a myth that has been propagated by people, the likes of, Neil deGrasse Tyson even, that the distances are too far and the times are too long for interstellar travel. This is patently false, and we've known this since 1905, from Einstein's theory of special relativity. So if you can travel close to the speed of light, you don't even need to go faster than the speed of light. That's icing on the cake. If you can just go close to the speed of light, you can explore the entire galaxy, the entire universe if you can go fast enough.
When the United States and China clash, the world will never be the same, especially when forces beyond reality threaten to intervene. What if the United States went to war with the People's Republic of China? How would these rivals fight for supremacy on land, sea, air, and across the stochastic streams of time? What wonder weapons would be unleashed? What horrors would emerge from the irradiated sludge of the South China Sea? What heroes would rise and forever change the course of history? Tread into the deepest and darkest dimensions of the multiverse, gaze through a kaleidoscope of fractured realities, and bear witness to the disturbing visions of World War III from today's greatest minds in science fiction, fantasy, and horror. Weird World War, China. Available now from Baen Books at baen.com.
Now, the issue is we don't know how one would have fuel and or propellant for that. But that's not a question of physics. That's a question of engineering. And if we look at our own history, engineers are always finding workarounds. Airplanes are not supposed to work, but they do. We have found workarounds for air travel, for space travel. We have, satellites in low Earth orbit. We've sent rocket to the moon. We've sent craft to Mars. We've explored our solar system. We've sent craft like the Voyagers outside of our solar system. And yet all of these are things that would have been considered impossible 100, 150 years ago and claimed to be impossible with our knowledge of physics at the time. We were misunderstanding how to find clever engineering principles to work around and within the laws of physics. So we had for centuries the necessary mathematical equations to create an airplane. So what took us so long, right? Because engineering is hard. Mm-hmm. And so I think that number one, you need relativistic propulsion, which is going to require fuel. We don't know what potential fuel sources you could have to be able to achieve this. So I'm not claiming, it's a solved problem, but I'm claiming that it doesn't necessarily require new physics, just new engineering of things we already know, potentially. If you could travel, as I said, close to the speed of light, you would need to have the fuel to do that and the shielding. We also don't know how to solve the shielding because, you hit a speck of dust going, close to the speed of light, destroys your spacecraft. So there are technical hurdles. But if you could get the right fuel and the right shielding, and you can travel close to the speed of light, then interstellar travel becomes possible.
Now, while the materials problem is probably one of the biggest problems in materials, metamaterials, whatever you want to call it, that would have to be solved, we do have clues, right, in terms of some of this technology. So when I say clues, I'm going to give you two examples. So we have these, the data from these Tic Tac sightings that were, off the USS Roosevelt and off the USS Nimitz, or observed on those, from those two locations. The other piece too is kind of intriguing because the world of academia, my impression as an outsider is you have to be extremely careful about what you claim and what you say. Otherwise you will be attacked a lot. So as an example, Avi Loeb just did a magnetic sled experiment last year with a neodymium magnet. He trawled about a mile down off the coast of Papua New Guinea. And, he wrote a paper about it. He, said it could have, and found certain materials that some of which were represented at 1,000 times what you would expect from any element in the solar system. He also confirmed that the object that had broken up in the atmosphere that had created or deposited those elements came from outside of the solar system using data from U.S. Spacecom, right? And I think it was like 99.99%. In his paper, though, there's this little chart that just shows these elements, right? If you just take it a step further and identify the elements and just do a quick search on what those elements would be used for, there's two kind of buckets. One is in either fusion reactor or fusion bomb design, and the second is spacecraft design. So like niobium, elements that help strengthen steel alloys. So I'm not saying that that's from some sort of interstellar probe or interstellar, space junk from an ancient civilization, but it could be. You plug all those elements into ChatGPT, those are the first two hits, that it's the satellite or spacecraft, etc. Right? So, but he can't come out and say that there's an X% chance that all he can say is, well, I'll do an entire paper on a magma-like planet that could conceivably produce these elements. And then I'll suggest in one sentence, or it could be artificial. That one sentence he was attacked. But anyway, regardless, you have debris. You also have the Ubatuba debris, where there's these novel isotopic ratios. So anyway, so you have observational data from sightings, and then you also have actual materials. Based on that, what do you think this points to in terms of craft design that we might have to look at in order to achieve relativistic speeds or even faster than light travel?
To advertise on Through a Glass Darkly, email throughaglassdarkly@gmail.com.
Well, honestly, it's too hodgepodgey. It doesn't point to anything, because even if you had, let's say, the fusion reactor you mentioned, that's still not enough power to get up to the speed of light, even with a fusion generator. And where do you fuel it from? You have, a ramjet, like if you start ramjet, that doesn't seem to quite work. There might not be, probably not enough, raw materials in the interstellar medium for that. So those buckets you just pointed to are how humans would use those materials.
Right.
So you'd have to think way outside of the box, I think. I think it's being too limiting to try to extrapolate what we would do with those elements and isotopes. Like in the Ubatuba case, I think it was extremely pure magnesium, I believe, which is like, that seems like a really stupid design for a craft that's like highly flammable, because we're probably missing something. We're not, we're just not making the connection. We're just not.
Yeah, and it was the weird isotopic ratios that were strange there too. It's like magnesium 24 versus magnesium 26.
Well, but it was inconclusive, unfortunately, which seems to be it's always the case. It's like the conclusion of every X-Files episode where like, oh, we get this close, but it's like, so the isotopic ratios are always inconclusive, because you can always, it's really hard, but you could do isotopic separation on Earth. So really, it proves nothing conclusively, unfortunately. It's intriguing, though, if you do get isotopic ratios that match some other solar system, that is an important hint, like you were saying. But if you say that, you said you have to be really careful in what you say. I find that really funny, because Avi is like, in my mind, is the opposite of careful. He says whatever the hell he wants to. I'm not saying that as a criticism, because what you were saying about academia, I have to correct you on something. You actually don't have to be that careful. Not after you have tenure. After you're unfireable, you can say whatever the hell you want. And so that's 6 years after you've been a professor if you make it to tenure. Then you're unfireable most of the time. I mean, they can still be really mean to you. For example, this has not happened to Avi. He's very lucky. But John Mack, who's also at Harvard, they like moved his office off campus. Like, they can't fire you, but they can make life really, really, really hard, and they can still try to fire you. However,
he was also hit by a car, which is odd.
Yeah, well, no, I think it was just a drunk drive conspiracy there. But basically, I think that there is an advantage to at least the academic system as it currently is in the United States. It has plenty of downside of being, crusty and too conservative in terms of allowing new ideas. But the plus side is you've got some latitude with crazy ideas once you're more senior. So Avi can get away with stuff like that. He fires off, a Medium essay or another article on Archive on some crazy thing, or like, claiming Oumuamua might have been a probe. And yes, he's attacked, but the attacks, he can just like repel them, and he can just double down. You know what I mean? And he can attack. He can repel the attacks and double down in a way that you couldn't do if you were a more junior professor or if you were in a different line of work than academia.
Yeah, and the attacks that he gets also were really absurd, right? So I think one of the attacks he got for that experiment was that, oh, it's a truck. I mean, do you know of any trucks that have 1,000 times the uranium signature that you would have in the solar system?
Oh no! What was meant with the truck was that he was looking at the wrong location. It's not a physical truck at the bottom of the ocean. What they were talking about is that a passing truck set off the sensor instead of the
I see.
By Avi, yeah.
Okay,
no, we're not talking about a truck at the bottom of the Pacific.
So they were criticizing Spacecom, basically. They were saying all their sensors that we spend trillions of dollars on are wrong. Is basically the argument.
Yeah.
Okay.
Which is the same That's the same argument for the Nimitz and Princeton encounters with the Tic Tac. It's the same argument. Is that the Spy 1 Bravo, this like most advanced system in the world, has glitches, that we spent billions or trillions of dollars on. Yeah, it's the same old argument, is that when there's something too crazy that you refuse to acknowledge an exotic possibility of, you always just say the data is in error, the sensor is in error. Regardless of whether it's a human witness, if it's not a human witness, if it's a machine, then the new thing is like, oh, it was a software glitch or blah, blah, blah. There's always an excuse that the observation...
And look, it could be, right? We shouldn't like decry that as like that's always wrong. Like it could be. It
could be, but over and over again for decades across multiple encounters, no, I think that's it. I think we're well beyond that point now because we have way too many data sets showing that go back to the 1950s. You've got Kevin always mentions you've got Herman Oberth, always talking about radar detections at Mach 50 and Mach 60. We can't do that today, even still. So I think we need to get past this data as an error, because the data could have been error here and here and here, but really everywhere for all of the cases, it's just getting ridiculous.
In those particular cases, and again, you might know this because this is, all the data is very likely, or some of it's very likely classified.
Mm-hmm,
Did they detect any electromagnetic radiation that might be implied by like a gravitational blue shift? So X-rays, gamma rays, stuff like that emanating from these objects? Or is that... Again, I don't know if you know that or not, but I thought I'd throw that out there.
I only have rumors and hearsay that say yes. But again, it's always rumors and hearsay, which is then it's very easy for a skeptic to say, well, where's the data? The problem is that all the good stuff is classified. But that's one of the reasons why when we went out to detect UAPs, me and Kevin Knuth, whom you've already interviewed as part of the UAPX team, we brought radiation detectors because that's one of the things that has been alleged. Not just probably hiding classified data, but you have stories of burns, like in the recent French report from Japan just a couple years ago. I'm not talking about the Cometa report from 1999, but the more recent report where before it was translated into English, my wife, who knows French, translated the juicy bits of the French report for me, and they mentioned radiation burns. Gary Nolan's always talking about that. Again, we don't have the hard data, but we've got stories like Stefan Michalak at a lake in Canada. I believe he's a Polish-Canadian who claims to have had radiation-type burns from a UAP encounter of an actual ship on the ground. And so that's the famous Falcon Lake encounter. Mm-hmm. So I think that – and then, of course, there's Rendlesham Forest, where you had Senator John McCain going to bat for a veteran who was claiming disability for literally being hurt, like getting radiation sickness from a UAP.
And they wouldn't release his medical records to
I know.
him.
And they still don't. They still didn't. I know. They didn't release his own medical records to him. How insane is that? And that's really to me that's like pleading the Fifth Amendment, where they're not admitting that there's weird stuff, but they're admitting it by lack of transparency, I think. So I think that you can't fake X-rays, gamma rays. That's much harder to fake than here's a blurry UFO image. So that's why I'm all about supplementing photographic and video evidence, even infrared, of UAP, going further and looking for signatures of electromagnetic radiation. Maybe it's a byproduct of exotic propulsion or something, right? We don't know. It would
What
be,
about?
it could be
No,
tied
go
to
ahead.
relativistic propulsion, like you were just pointing out. If I'm traveling close to the speed of light, let's say I'm an interstellar craft from an advanced civilization, and to be clear, while we've seen really high speeds, we've seen nothing approaching what I'm talking about. But I'm talking about going in between star systems. If that's what's going on, you would need there would be a byproduct of relativistic propulsion, Doppler blue shift, where when a craft is approaching, it's redshift the opposite way, moving away. But if a craft is approaching you and has Doppler blue shift, that Doppler blue shift can take radio, radar, microwave, infrared, and visible light, things like that, and shift it up to X-ray and gamma ray. And I've talked to the famous Eric Davis about these kinds of things, and he absolutely thinks this is part of the equation, not just in terms of special relativistic propulsion, but also general relativistic propulsion, where you're warping space-time. You could also have Doppler blue shift as a consequence of such exotic propulsion. And that's a signature that we should be able to simulate and predict and be allowed to, as scientists, test some of these ideas in terms of SETI, in terms of like looking for evidence of civilizations. These are the kinds of signals that are reasonable to ask if they're out there, not just in the Earth's atmospheric domain, but in interstellar space.
Now, let's say that we're able to get to some of these speeds. What are some of the technological concepts that are kind of out? Like, we could talk about Alcubierre drive, all that sort of stuff, but what are some of the technological concepts? And I know you've kind of, and correct me if I'm wrong, you've classified it into kind of two categories. There's kind of relativistic travel, just traveling very close to the speed of light. And then there's also faster than light
Correct.
propulsion systems. So in those two buckets, what are some of the options that are potential? It doesn't mean that they will be, but kind of some of the concepts that people are exploring now.
Yeah, so I can cover both. So for slower than light travel, we really don't have a concept for how we would get past the shielding and the fuel problems. So the shielding problem is so bad that basically there is no known material. Doesn't matter, element, compound, there's nothing we could make a ship out of. And I don't care if it's tungsten, osmium. The problem is going back to the Doppler blue shift, there's another aspect to it, which is, let's say you're going near this, you're going near the speed of light, and you're sitting on the bridge like Charlton Heston, at the beginning of Planet of the Apes. Starlight is now fatal because starlight's been blue shifted up to gamma ray. So the starlight coming through your window is fatal. How do you solve that? Oh, okay, you don't have a window, you have a giant piece of metal. That's not good enough, because if you're traveling fast enough, let's say, okay, you have no windows because, that's just to make things pretty in TV and movies. That's not good enough. Well, you can have some hunk of material, any material we can think of. It's not going to be good enough because, again, as I mentioned earlier, hit a speck of dust traveling near the speed of light, and bam, there goes your whole ship. Because that speck of dust it might be quote unquote stationary in the galactic rest frame or something, but you are coming at it, near the speed of light. So we don't know how to solve that. We also don't know how to solve the fuel problem, although we can speculate. On the material science, I can't even speculate on what materials would solve that problem because it's such a hard problem. You could have shielding, like sci-fi always has, raise the shields, right, on Star Trek and Star Wars. But what would that shielding do? Everyone always defaults to electromagnetic, and I've gotten into huge fights with UAP folks. I'm like, what about neutral particles? And I get blank stares, and then they get angry with me that I'm being closed-minded. I'm like, no. I'm one of the most open-minded scientists you'll ever talk to. I'm legitimately asking the question, what do we do for neutral particles? You cannot shield against neutral particles with magical electromagnetic shields. And so what about neutrons? What about neutral particles? What about gamma rays, which are neutral? And so you cannot shield against everything with the current technology and extrapolations we can think of in terms of materials and in terms of some electromagnetic shielding. That's not good enough. In terms of fuel, I can at least speculate. There are all kinds of potential fuels we haven't thought of, like dark matter. that I work on, and dark energy, the energy of the universe itself. We don't know how to harness that or whether it would be useful, but I think it's really interesting that we don't understand 95% of the mass energy of the universe. So maybe there's some way to tap in to dark matter and or dark energy as some sort of natural propellant or natural fuel, so you don't need to take fuel with you. We don't know how we would do that, though, so I'm just speculating. Now, on the faster than light stuff, I have to reemphasize that it's completely unnecessary. I say this on every interview, that the faster than light is completely unnecessary for exploring the universe. So I'll give you an example of a homework problem I give my students. How long does it take to reach the Andromeda Galaxy? And you've probably heard, 2 million years at the speed of light. False. If I could go 0.1 meters per second slower than the speed of light, I could get there in 50 years. Everyone on Earth is dead. 2 million years will have elapsed on Earth. So the only benefit of faster than light travel is if I want to get back home for dinner. But if I don't care and I just want to be a nomad, you become nomadic and explore the universe, faster than light travel is completely unnecessary. So the main benefit of the concepts from faster than light travel is to take the same concept and apply it to slower than light travel. So the main concept is space-time warping, which hypothetically could get you faster than light travel. Everyone always talks about Alcubierre. Alcubierre, way outdated. We've gone way beyond Alcubierre. Alcubierre, his work was very important. It was the seminal paper. But after Alcubierre, we had Notario, we have, Lenz, we have Eric Davis, we have Travis Taylor's written a paper on it, we have Lavinia Heisenberg. We've got like Bobrick and Mateer. We've got like 15, 20 more papers that nobody talks about. Nobody talks about them because we only talk about Alcubierre. But Alcubierre's first paper, while very important, established this whole thing, his first paper was wrong. It was an approximation of a zero-dimensional point and was just a first concept paper. Right. But basically, the continued discussion of Alcubierre, as if Alcubierre was the only thing out there, would be the equivalent of, in air travel, constantly talking about Wilbur and Orville's first airplane and pretending there are no like F-19s or 747s. So we've gone way beyond that. So we've got some really great progress, especially in the last 5 years. Lots of scientific publications out there in mainstream journals. Very few attacks even. Lots of mainstream journals have published on how to do faster than light travel by warping space-time. And the key ingredient there is negative energy. We don't know how to get that at large scales. And when I say negative energy, I have to be really, really specific what I mean. It's a type of anti-gravity-like effect that's very specific. It's the same thing that's required for warp drive, for wormholes, and for time travel to the past. They all have this thing called exotic material where you'd need matter with a negative energy density. We don't know how to create that en masse. We don't. There are papers by, for example, Eric Davis, where he has some ideas on how to take like the quantum mechanical 0-point energy and try to magnify that, but that is beyond our abilities. Now, the good news is again, going back to the point of faster than light being not necessary, warping of space-time is a great way to travel at any speed. So if it doesn't work for faster than light, heck, it can work for going, 10,000 miles an hour, way slower instead. And that ties into what we've been seeing with UAP, because what if things like the Tic Tac really have a warp bubble around them? That is not necessarily for faster than light travel. It could be later when it leaves the atmosphere, right? But in the atmosphere and in low Earth orbit and things like that, maybe it's just useful for much lower speeds, but without the need for a traditional throwing out a propellant out the back. So the beautiful idea about space-time warping is a common misconception is that it's only for faster than light travel. No, actually, if you had that technology, you would use that to go 30 miles an hour even, because it's so much better. And that would potentially explain why you have, for example, no sonic booms, no fireballs from UAP that seem to be going faster than the speed of sound at the temperature and pressure conditions of the atmosphere. We can explain that. We may be able to explain that by space-time warping. We actually don't even need to go to something as exotic as space-time warping. You could ionize the air. These are old ideas. There's Lee Camerabo from RPI. There's all these old ideas for how to ionize the air and push the air out of the way. Modern Russian hypersonic missiles used in Ukraine use a similar technology. So it is possible to be supersonic without sonic booms, without even going into the space-time warping ultra-speculative domain. But that domain is if I was dreaming up an advanced civilization, that's where I would eventually want to get to if I was an advanced civilization with space-time warping, to use it for any propulsion at almost any scale.
Now, you mentioned something about negative gravity, negative mass. Mm-hmm. So what about phonons? How do those theoretical particles, I think they're like quantum scale particles, like vibrational particles that are either theorized, or I don't know if they're real, I don't know if they've been measured or just theorized, but what about those? Because they theoretically have negative mass, right? Or negative gravity.
They do not. They're real and measured, and we've been working with them for decades. In fact, we use them in dark matter detection. So phonons are quanta of vibration, just like how photons are quanta of light. So phonons are just crystal vibrations. They do not have negative mass or energy. You'll find papers that claim that. That's artificial. Basically, phonons are not, they're not as real. They're real in the sense that we measure them. They're not the same level of ontology as photons. Basically, they're just vibrations in a crystal lattice. They're not like their own particle or wave. Okay. And so basically, when we talk about negative energy phonons, that's only to describe the dispersion relation of phonons in a particular crystal. So it's a mathematical tool. It's not going to help you with anything I just said. It's completely not connected or used. And I can say it with confidence because we've been using phonons for I don't know how many decades. I mean, they're old hat. I mean, we use them every day in physics.
Okay, so what are some of the, kind of delving a little bit more into the concepts of faster than light proposed technologies? What would some of these things look like?
Well, all right, I'll answer, but remember, you're always going back to the faster than light. It's not needed. Like, faster than light could end up being wrong. It could end up being against the laws of physics. Does that mean we can't explore the universe? No, not at all.
Well, let's call it gravity like space-time modification, gravity modification, anti-grav, whatever. That's
let's call it space-time warping, because that's general. It can be faster than light, or if that turns out to be impossible, it could also be used for slower than light. So what you need is, so phonons are not going to cut it, photons are not going to cut it. You need something like the 0-point energy. Let me explain what that is, because it's not a myth. It was not made up by experiencers.
It's Casimir effect. It's something.
Well, the Casimir effect is a consequence of the 0-point energy. They're not synonymous. It's an experimental consequence. So what's happening is that all throughout, even quote unquote perfectly empty space, like the vacuum of space, you have particle antiparticle, so particle antimatter particle pairs popping in and out of existence, like electron positron, proton antiproton, and these are known as virtual particles. And to still follow physical conservation laws, they typically appear in particle antiparticle pairs, and they will pop in and out of existence even in a vacuum. And so there are many almost synonymous terms that fly around: 0-point energy, dark energy, quantum, which we think is the same thing but might not be, quantum mechanical energy, virtual particle antiparticle pairs. These are maybe all the same thing, or there might be some subtle differences, but for the intents and purposes of a non-scientific, non-technical conversation, we can say they're all about the same thing. And basically what this means is that empty space is not empty, and you can capitalize on this energy. However, we don't know how to do this on a large scale, as I said. Mm-hmm. So, but this is the kind of stuff you'd need to scale up to achieve space-time warping, wormholes, including time travel. As I mentioned, these exotic ideas, they all require the same thing. They all require something that has a negative energy density, and vacuum energy does seem to fit the bill. And why does it have, or could it have negative energy? I don't want to get into a technical discussion of energy densities and pressures and stuff and try to I'm going to try to simplify it, but I might be oversimplifying a little bit to make it inaccurate, but try to, present it non-technically. But basically, virtual particles don't have to obey the same physical principles as real particles. So these particles that are popping in and out of existence don't have to just have positive mass and positive energy. They could have, impossible for real particles to have permanently, is they can have negative mass, negative kinetic energy. And so basically what that means is they seem to have the right property or properties that is the type of material that we need to harness for something like space-time warping. And sort of the simple way of thinking about this is that positive gravity things are not going to let you do space-time warping. That I can't give you a deep reason why. That's just the math. That's just how the math works. Attractive gravity is not good enough to create space-time warping. You need something that has an anti-gravity-like effect in order to warp space-time, in order to hold a wormhole open, because even if you could create a wormhole, you can't hold it open without something that has a negative energy density. All the examples of negative energy, like you mentioned phonons and crystal vibrations, I've also read articles where there have been all kinds of quantum mechanical tricks we've used to create something that looks like and acts like it has negative mass in the lab, but it doesn't. And so all these articles one can find, and then the popular, press will pick it up like, oh, look, it's negative mass. No, it's not. It's an analogy for how negative mass would behave. But I'm sorry, an analogy is not going to let you build a spacecraft. And so right now, I'm not saying we won't have it one day. I'm optimistic that as humans, as our technology develops, and hell, I think somebody else has already figured it out somewhere from someplace else. And so I'm optimistic. But what I'm saying is that with our current level of knowledge, we don't know how to take the little tiny bits of negative energy that exist in the vacuum. We don't know how to scale that up from like a tiny useless amount, like not enough to power a 9-volt battery. How do you scale that up to something that allows you to warp space-time? We don't know how to do that. So it's really a quest for finding sources of negative energy, and that is really hard because we don't even have, it's not just that we have theories that predict that negative energy particles should exist. It's worse than that. We don't even have theories or models that predict that such things should exist at scale in large amounts. So it's a two levels of impossible that make it very, very hard to see a path forward despite my optimism.
And why aren't folks spending more time and resources on this problem? In other words, and also does the government spend time and resources on this problem?
No.
In secret at all?
Maybe in secret, who knows, right? Because if Grush is right and there's black projects on the black books that aren't part of the accounting, then I think it's possible. But I'd be really frustrated if that was the case, because a space travel could help all of humanity. You don't need to turn into a weapon. It can just be propulsion. It has nothing to do with weapons. And so I know there's always the connection. If you have a huge new source of energy, you could always turn into a weapon. You can always turn anything into a weapon. But I think that in order to make progress on a topic as complicated as space travel, we would need to engage more scientists and engineers. So if it's in secret, that means we have too few people. Because if you think about the size of the Manhattan Project and think about how quickly it was discovered. Well, after we dropped the bomb on Japan, we had to admit it existed. But you need like a Manhattan project size thing or even bigger in order to solve something like space travel. It's going to be really hard to do that if it remains entirely classified. But we're not publicly spending, to answer your original question, we're absolutely not publicly spending anything on any of these exotic ideas. I think NASA did at one point, but then, its budget got cut again. I think at one point NASA had like an exotic propulsion and space-time warp drive was a possibility, but I think that got killed. Because the first thing that's going to go when you have budget cuts are things that are high risk, high return. Where like, in the future, it might work, but there's a risk. The risk is it doesn't work and it never works. And you spend 50 years and waste trillions of dollars and it doesn't work. Personally, I think we should try crazy ideas and give them some money, but there's no money in it. There's no public money in anything that I just said, the last 10 or 15 minutes or more, it's not a small amount of money. I believe it's literally zero in the US and potentially in other countries as well.
So why are they funding things like string theory?
Ooh, I have to be careful with this because two of my friends are string theorists. The two offices next to mine are both string theorists.
Yeah, I'll let you off the hook if you need to be. But
well, no,
it's a fair question, right? It's a fair question.
No, I actually think it's an unfair question because what do you mean by funding string theory? This is string theory's funding, and this is anything else. Like, I don't think you understand. String theory doesn't actually use any funding other than for people to live and
Math.
eat. Yeah,
right. It's math. It's
math. There's no experiment. So basically, all that funding for string theory is for professor salaries, students' summer salaries, and not even computers, pen and pencil. So it's really not like if you eliminated tomorrow all string theory budgets and put a bunch of physicists on the street, you know what impact it would have on what we were talking about? None. It would pay for maybe 10 seconds of the research that we were just talking about. It's trivially a small amount of money.
So what are the practical kind of long-term uses of string theory? And I'm asking that not as a challenge, but I'm just genuinely curious.
None. It's expanding the frontiers of human knowledge, just like the discovery of the Higgs boson. That doesn't have any practical applications. But basically, string theory has the same question could be asked of string theory that's been asked of any theory of matter for centuries. And in the past, every theory of matter actually became important and allowed us to do new things. So, for example, you could have asked 2 centuries ago, or a century and a half ago, or something like that. You know, I lose track of time in the 21st century. You could have asked the same question: what good is electromagnetism? Who cares about electricity and magnetism? And now it runs our entire society, power plants, the computers you and I are sitting on. Mm-hmm. And it's the same thing with string theory, I think, or dark matter for that matter. And it could just be that the practical applications are just centuries ahead of where we are right now. I can't even give you a speculative one for string theory.
Okay, so we talked a little bit about hidden, potentially secret programs, et cetera. We don't know. They're secret, right?
Yep.
And we also talked about the use of gravity modification, anti-gravity, whatever, in order to warp space-time in terms of getting to distant locations.
Mm-hmm.
Now that's warping space. What about warping time? And what are the implications of that? Other than getting to your destination faster and having kind of the grandfather paradox and all that good stuff.
They're not separable. They're the same thing. Space and time are two sides of the same coin. You can't ask, well, what are the consequences for one or the other? It doesn't work that way. Any time machine is a spaceship, and any spaceship is a time machine. That goes back to my relativistic travel. If you're traveling slower than the speed of light, you've got a one-way ticket to the future, guaranteed. So in my example, if you go to the Andromeda Galaxy and then turn around and come back at 0.1 meters per second slower than the speed of light, and you make this round trip, several million years will have elapsed on Earth. So you've got a one-way ticket to the future. In terms of the space-time warping, we were talking about for slower or faster than light. If you could go faster than light, you automatically have time travel to the past ability. So again, those are inseparable. So if I can't see how you would avoid it. If you have the ability to warp space-time to go faster than the speed of light, I think that in most models, I think that almost automatically means you now also have the ability to travel to the past as well if you wish to. So I don't think those are separable. The consequences are that slower than light relativistic travel guarantees you the ability to go to the future one way. That's guaranteed. That's inseparable. You got a time machine. And if you could go faster than light, you have potentially at least the ability to go to the past, and it's hard to separate. So you can't separate a spaceship as a time machine and a time machine as a spaceship. That when I say spaceship, I use the term loosely. Your car is a spaceship in the sense that it takes you from one point in space to another. And your car is also a time machine on a very small scale. You have a very, very small amount of time dilation that occurs when you go 30 or 60 miles an hour. So you cannot separate space.
Okay, now we have about 9 minutes left, I think, in this particular episode. So I'm not trying to broaden this, but your answer raises a lot more questions. So,
Of course.
now we talked about potential secret programs, etc. And one of the reasons that they might want to keep something like that quiet is having a weapon, right? The other reason I think one could posit is if the gravity modification, well, I mean, not if, it does imply the ability, if you were able to achieve faster than light travel, sort of, time machine, going back into the past. Now, in terms of, let's just step back. I know you mentioned that we don't know if faster than light travel is possible using gravity modification. It's just theorized. But let's say it is possible. What are some of or who's kind of worked on the implications of the effects that you might have if you're able to go back to the past, alter things, affect the future? Like, is it just like a parallel timeline? Is it some recursive time loop? What have folks theorized about those different options? Again, that's a huge topic. I know.
Oh, everything under the sun has been theorized. Is it multiverse? Oh, maybe, maybe not. Is it self-consistency? You try to change the past and you actually end up fulfilling it, prophetically. Like, there's that option as well. There's only one universe and you can just fulfill the past. There's hundreds or thousands of papers, including serious scientific articles written about this. I can throw out some names. There's Ron Mallett. There's Seth Lloyd, David Deutsch. I actually have a TED talk on this, a TEDx talk. I've got a YouTube video about time travel, and I cover all of this. It's already got 750,000 views on YouTube. So you can just check that out. My last name is unique, so it's very easy to find that link. But I have like an 18-minute talk where I cover all of this as fast as I can. My favorite one, though, that is kind of one of the latest ideas, is that if you went back and you could change the past, it would look like you succeeded initially. But then it creates a time loop, and on every iteration of the time loop, you get closer to failing. And then you don't remember the loops. It's kind of like, did they really happen?
So it's recursive. That's like a recursive.
But temporarily. So basically, let's say and again, this is so speculative. We're just pulling this out of our butts because we don't even know if time travel is possible. But this is my favorite idea. So basically, let's say you went back in time to assassinate Hitler. Paradox, right? Because then you change, you're not born, blah, blah, blah. Okay, what happens is you succeed in assassinating Hitler, which then locks the universe into a loop. And on every iteration of the loop, you come closer to failing until you fail to assassinate Hitler, and the normal timeline progresses again. And so then from your perspective as a time traveler, you're like, what the hell? My gun jammed, or I got arrested. From the perspective of the time traveler, then it looks like the Nabokov self-consistency principle, where you cannot change the past, you can only fulfill it. And so that is one potential idea. All of the ideas have been written about by everybody already. Like, I don't think there's been something new in time travel until the idea I just said. Like, it's the same things over and over again. But the two main ones are always multiverse and self-consistency are the two main explanations. But there are all these subcategories of each of them.
Has anyone developed like mathematics to try to explain this stuff?
Yes, using quantum mechanics. So I mentioned there's Seth Lloyd, David Deutsch have looked into that. Ron Mallett has looked at it from the general relativity perspective. The idea, the quantum mechanical math behind it was there was an attempt to try to address the grandfather paradox by simulating, again, not for real, but simulating time travel in the lab. I just saw another article about this just last week about using particles and simulating how you can interact with yourself in the past, where like the particles represent, like human beings time travel. Again, it's not like literal. It's not literally, we're not literally time traveling these particles in the lab. And one idea has been that if you could, let's say, go back in time, kill your grandfather, then one of the ideas I've heard is that you're like Schrodinger's cat, and you're kind of both dead and alive at the same time then, because you succeeded at killing your grandfather and you did it. And both are true at the same time, because otherwise, how are you born? Now, the thing is, it's one thing to talk about one subatomic particle, both existing and not existing, but a human being that's a collection of many, 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 many atoms, that's really hard to understand what that means. Then, so, okay, if I killed my grandfather, what does that mean? Like, I don't vanish like in Back to the Future, but when I come back to the present, I have, no social security number, no driver's license, nobody remembers me. Like, is that how it works? Like, basically, it's not clear how to extrapolate from these tabletop experiments with subatomic particles, how to extrapolate the mathematics to be like, what is it like to be 50% dead, 50% alive? What does that mean for a human being? And so nobody understands, I think, how to extrapolate that math to what that would mean for a real-life physical time travel.
What about theory? I mean, I don't even know if this is a theory, but theories that time is simultaneous. As an example, like, let's just say you have a radio station, right? And you're just shifting into different frequencies, forward and backwards. All those stations are playing simultaneously, but you only hear one when you're on a particular frequency. Is that a theory that has any cachet, or is that just science fiction gobbledygook?
You mean, do the past and the future simultaneously exist? Is that what you're saying?
Yeah.
Kind of. It's a cute analogy, but it doesn't really hold water in with our modern understanding. And here's why. It could be partially correct. It could be that the past exists, period, and is just as real as the present, but not the future. Let me explain why. There's a good reason. I'm not just throwing that out there. And again, this could be wrong. I'm just giving you our current best understanding. I can say with a high degree of confidence that the past probably exists, and here's why. Because we know from Einstein's theory of special relativity, my present, your present, is always someone else's past, and vice versa. And that's because of the relativistic time dilation we were talking about earlier. So basically, we've already known since 1905 from Einstein's seminal work, there's no universal clock. Like, the whole universe is ticking away. That does not work. There is no such thing as simultaneity. So anyone's past is someone else's present, and vice versa. So right now, our conversation that we're having right now is already someone else's past, depending on how fast they're moving. You're moving close to the speed of light. And so now this should be extendable. And by replacing the words present and past with future and present, we should be able to extend the argument I just said to say the entire future exists. But we can't. And here's the reason why. Now let's add quantum mechanics to the mix. We've got relativity. Now let's add one of these other great discoveries of 20th century science and math, of physics, is quantum mechanics. Future is not settled in quantum mechanics. It is not predictable, period. Doesn't matter what computers you build. Doesn't matter what you do. If you take the example, let's take a single atom that's radioactive. Let's say a single atom of uranium. We know it has a half-life of this many years. That just tells me on average when it's going to decay if I have a large number of atoms. But what about one atom? No math, no equation, no theory, no model tells me when that one atom will decay. And so as a result of our current understanding of quantum mechanics, the future cannot be set in stone. That does not seem possible. So the current best guess we have of how time works, and again, it could all be an illusion, but I don't like getting into that because then it's not science anymore, it's philosophy. It's like, that's good for over beers at 3 a.m., but I'm a scientist. I deal with the real world. I don't want to speculate that, time is an illusion, man. Like, yeah, good, that's a great idea, but what consequences does that have for my daily life? That's not a practical, that doesn't have real life consequences. So I think one way of looking at time is that the universe, the past exists, and we're moving towards the future, but it's not a straight line. We're like, this is the present for the entire universe. It's some wavy, bubbly thing where some parts of the universe are ahead of others. So think of it as like, there's like a block. This is, I think, this is similar to the block universe. I'm giving you like a modified version of that, where like, think of the universe as like everywhere in space goes this way and then time goes this way. But you can't think of it as like The sheets are the present. Think of it as like this wavy, rumbly river where it's come non-linear and some parts bubble up faster than others. And so you can think of it as the time is progressing toward the future, but not at the same rate for everyone. I think that's the best compromise viewpoint, because all of the other viewpoints I think are too simplistic. Everyone's always got their favorite philosophy where they want to solve the universe in one sentence, but the universe is complicated. I think all these things like time is an illusion, or like your radio station analogy, I think those are all too simple. And I think the truth is way more complicated.
Okay, any final words for the audience?
For the first half?
Yeah.
I think we need to solve the UAP mystery, because if we are really talking about non-human intelligence that's operating some kind of craft, we need to learn how to build these types of craft, because it's inevitable that humanity is wiped out if we don't become an interplanetary species. Whether it's World War III, so it's our fault, whether it's a pandemic that kills everyone, whether it's some other type of natural disaster, the Yellowstone supervolcano, or we miss an asteroid heading towards us and it's too late to divert it and it hits us. Basically, I think that in order for humanity to survive, we have to become a multiplanetary species. And I think that even if not all UFOs are, alien spacecraft, what if speculating about that inspires us to build the technologies we need to survive as a race?
All right. Thank you very much, Dr. Szydagis. It has been an absolute pleasure, and I will talk to you soon.
Thank you.
If you enjoyed today's video, please hit like and subscribe, and also hit the notification button so you can be notified whenever I post new content. Thank you. Now, if you're enjoying the channel and you want to support it, there are several things you can do. In fact, there are 5 things you can do. The first thing you can do is just buy my books. I got plenty of books out in the market right now, and I would prefer that folks buy a book rather than giving me direct support, because they get something out of it. They get a real tangible product. The second way you can support me is by becoming a member on YouTube or becoming a patron on Patreon. And just go to either site and it'll explain everything. The third way you can support the channel is by checking out my merch site, which is here. There's plenty of stuff that you can get to support the channel. And I'd appreciate that you have it and can wear it. Not only do you help support the channel, but you also help promote the channel, and I appreciate that. The fourth way that you can support the channel, and this is really easy, is anytime you want to buy something on Amazon, literally just go to the description below and click on any link, literally any link. The channel gets a cut of that, and it costs you no extra money. You just go through the link, as I'm part of the Amazon Affiliates Club. The fifth and final way you can support the channel is through donations. Now, I don't prefer these because it's more of an expression of gratitude, but you don't really get anything out of it as a subscriber to the channel. However, if you decide to do these options, there's 2 options. There's Buy Me a Coffee, which is a separate site, and there's also, you can go through YouTube with either a super chat, super sticker, or a super thanks. Again, I prefer Buy Me a Coffee because that organization takes less money than Amazon does. But either way, I appreciate any support you are willing to give the channel. So thank you very much, and keep watching. I really appreciate it.